In this video, we're going to continue working with complex numbers, and we have DeMoivres' theorem. There are two parts to DeMoivres' theorem. DeMoivres' theorem allows us to take a complex number, a plus bi, and raise it to an nth power. So we've got the power rule for DeMoivres' theorem. And then we also have what we're going to call the nth root portion of DeMoivres' theorem. We're going to work with the power portion right now. When you raise a binomial, a complex number, to a power. If you have a complex number that we call z, as you'll recall from a previous video, a plus bi is another way to say z and vice versa. That can be written as r times the quantity cosine of theta plus I sine of theta. Then, if you take that complex number z and raise it to the nth power, it's equivalent to r raised to the nth power times the cosine of n times theta plus I sine of n times theta. So what we're doing right here is we are taking the angle times n in both of those situations. And I'm going to walk through an example, so I'll show you. And this is equal to a plus bi raised to the nth power. So a very important formula, so important, let's highlight it. So we've got z to the n equals r to the n times the quantity cosine of n times theta plus I sine of n times theta. So here we have an example, -1 plus the square root of 3i raised to the 12th power. And that's the same thing as -1 plus the square root of 3 times I. I is not in the radical, and then we're going to raise that to the 12th power. So our first step is to find the r value, the n value, and theta. So we're going to find r, theta, and n. So we remember how to find r. R is equal to the square root of a squared plus b squared, so -1 squared plus the square root of 3 squared. And -1 squared is 1. And the square root of 3 squared is 3. And 1 plus 3 is 4, so the square root of 4 is equal to 2. And that's what r is equal to. Theta, in order to find theta, it might be helpful to graph or plot your complex number to make sure that when you're finding r and theta, that your answer makes sense. So when I plot this, I'm going to be in quadrant 2, and I'm going to be somewhere right around there. So definitely closer to the y-axis than I am to the x-axis. How do we find theta though? Theta, the reference angle for theta, is equal to the inverse tangent, absolute value of the inverse tangent of the square root of 3 over -1. And that would be y over x, the inverse tangent of y over x. So if I create an ordered pair here, y would be the square root of 3 over 2, and x would be 1/2. And in quadrant, that's a pi over 3 angle, but in quadrant 2, because that's where our complex number is located, in quadrant 2, we know that x is negative, y is positive. That's going to be 2 pi over 3. So we've got r, which is equal to 2. We have theta, which is equal to 2 pi over 3. It most definitely needs to be in the quadrant in which you are finding your complex numbers located in. And then n is going to equal the power that we're raising that complex number to. Okay, so once we find those values, then we substitute into our formula. And our formula is z to the nth power equals r to the n times cosine of n times theta plus I sine of n times theta. It helps to rewrite the formula down. It really does. So I've got an r value of 2 raised to the 12th power times the cosine of 12 times 2 pi over 3, and 12 times 2 pi over 3 is 8 pi. 2 to the 12th is going to be 4096. 2 to the 10th is 1024. 2 to the 11th would equal 2048, and 2 to the 12th would equal 4096. So this is a very common power right there, 2 to the 10th. You might want to have that memorized just in case it pops up on a non-calculator portion of an exam, such as the final exam. And then the cosine of 8 pi. So I'm finding out the cosine of 8 pi now. I'm going to use some colors. The cosine of 8 pi. Well, 8 pi is going to be on the positive x-axis. 0 pi, 2 pi, 4 pi, 6 pi, 8 pi. That's going to be right there where the ordered pair is 1, 0. So cosine of 8 pi is 1. The sine of 8 pi is 0. And when I distribute that, I get 4096. So if I were to raise negative 1 plus the square root of 3i to the 12th power, and you can try this in your calculator if you wanted to, you would get 4096. In the next video, we're going to do another example, which you could actually try right now, and then watch the next video to make sure that you've got all the steps and that you are feeling good before we progress to our nth roots.